this rumor to 1 million people here on campus? There are not 1 million people on campus, yeah, okay? There aren't 1 million people, so it's impossible. In fact, we can spread this rumor as fast as we want, but there's going to be a limit to how many people can actually know the limit, or know the rumor. A limit imposed by how many people are on campus. You know how, when we're getting to that Christmas season now, there's always going to be one toy or one gift or one piece of technology everyone has to have. I don't know what it's going to be this season. You know, you guys are too young to remember Cabbage. You probably had Cabbage Patch dolls as you were little girls, and the little boys. I don't know if they ever got into that or not, but it was a craze, and it happened. I forget the other thing since then, but we always go back to the Cabbage Patch. Do you realize what your parents went through to buy you those? If you got one for, pardon? Okay. Well, your folks probably didn't want to have to go through the hassles because everyone was out trying to buy one. Could you go buy one today? Yeah. No one really wants one, right? But what happens is that we sometimes have this must-have item, and sales skyrocket, and then they level off. Why? Because everyone has one. Okay? So if you go around and say how many people have a Cabbage Patch doll, probably the same number that had them 10 years ago. Okay, because you can only go so, there's a ceiling. You can only go so far. It happens a lot in business. Okay, here's another thing. We have one person on campus who has an infectious disease. Okay, they spread the disease. How many people could have that disease on campus? 1 million? No, it's like the rumor. It's going to skyrocket, and then all of a sudden it's going to level off. These are what are known as logistic functions. Logistic functions are those functions that have a growth to them, and then they level off because it's impossible to get beyond that. So let's take the inspires and let's look at the one that we have here on the screen. It's 1 divided by 1 plus e to the negative x power. One divided by 1 plus e. Now, someone on one of the quizzes used the letter e in here. There we go. And it can't be just the letter e. It has to be the special designed e, meaning that value that we have, to the negative 1. Okay. And, let's see if I have a window. Oh, what did I put in? Okay, never mind. I was thinking, why is that looking so weird? Of course it's looking weird, because it's not written correctly. There we go. There we go. Okay. So, trying to get this so we can see a little bit of that. Okay, so there is that logistic function, and again, it goes up and it levels off, and that's exactly what we see on these. Your textbook, or your Inspire has, let's see, to get to that, I'm going to go down and do a list and spreadsheet and statistics and a stack calculation, and you have a logistic regression that you can use. So if you think it's a logistic curve, you can, with the data that we have, you can actually impose a logistic regression equation on that. And we'd have to look at what D represents, whether we see D is 0 or D is not equal to 0. Okay, but just a little explanation of what those are. Now, we don't deal a whole lot with these, but they do come into play with some of our data. Okay, so here we go. Here is some data. A container contains 5 liters of 25% brine solution. The table shows concentrations of the mixture after adding L liters of a 75% brine solution to it. Use the regression feature to find the model for this, and it's a quadratic model of that. Graph the function, then compare it to a rational equation, a rational model, and then find the limit of both of those. I'm looking at the clocks. I want to make sure I give you back your quizzes, and some of you have some work we need to talk about on those. But let's practice this, if nothing else, for the sake of, well, let's see. How much of this do I need to have you do? For you to put that in your Inspires is not that difficult. Let's do that, and then if we have to, we'll come back and do this, finish it up. But I think we need to practice this. So go to a new page and put in a statistics, a spreadsheet, and we've got liters. So I'm going to spell out liters, and then move the cursor over and to the next one, and I'm just going to put a little abbreviation of the word concentration on that. Now, if you have the data in front of you, it's going to be easier. If not, you're going to have to listen very carefully as I tell you what values to put in here. So the inputs are, they go up by a half a unit, starting with 0. And so 0 and a half and 1 and 1 1/2 up to 4. So there should be 9 values in there. Okay. Concentrations, 0.25, 0.295, 0.333, 0.365, 0.393, 0.417, 0.438, 0.456, and 0.472. Now that I have mine in there, I'll let you see that. Okay. Use the regression. So go to Menu and go to Stats and Stat Calculations. And it says it's a quadratic, so we'll put in a quadratic regression. The input list is liters, so open that drop-down menu and make sure you select liters. The output list is concentration. I'm going to save this as F2. You can go down the list, and the first column of results will be in C. Our first one's in A, inputs in A, outputs in B. So the first result column that's going to show us any information will be in C. Okay, press Enter for OK. And if we look at this, we see that the leading coefficient is about 0.0080. If you hover there, you'll see a whole lot more. The linear coefficient is 0.0864, and more data would be there. And your constant term is 0.25, 23, 45, and it looks like it repeats 4 5s after that. And then we can look at the residual and all that. Okay, so we have now our quadratic regression. Let's graph this. So go to pick up a new page and make it a graphing page. And let's graph that. First of all, we need to get a scatter plot. So escape out of that, go to menu, go to graph type, and go down to scatter plot. So escape out of showing you the graph, the function. Menu, graph type, scatter plot. And your input, we need to put in liters. If you look over on the top row of your buttons, there's one called vars. Now in the black key, it's on the touch screen, it's on the opposite side of the Inspire as on the touch screen or the click. So we want to link to, and well, let's see. Did you find yours? It should be. Okay. Are you finding leaders there? Yours had it? Okay. Oh, let's do this. I'm going to. It may be, anyone else having difficulty finding that, or is it just me? Okay, you've got the, anyone else on ClickPad having difficulty finding that? You all found it? It's just two of us? Okay. Shouldn't be any problem if we go to, there we go. I don't know what happened. Go back, Kaylee, go back to the spreadsheet and then just do it again. It should be right there. Leaders, concentration, then for the other one. Now, I should be able to see what you're doing, but I want to just try and get this done. So there we have it. Obviously, I don't need the window that I've got. I'm going to make this, let's say, -1. I'm going to make this, what was my highest? I'll make that a 5 so I can see it. I don't need that to be very much, so -1. So if you're going in and changing the window, or if you're doing it like I am, just clicking on those, we can do a window that looks like that. That's our scatter plot. So we went into menu, graph type, and went down to scatter plot. Okay, now we need to go back into menu, graph type, and look at our function. And we're going to go up and pick up that function that we created. And how well does it? Okay, not bad. Not bad at all. Okay. Now you might need to watch this video again if you're not picking up on how to create all of those. But go back and look at that. Now it says a rational model for these data is this. We're not going to create it on there. We're just going to do this, but let's graph that also. And so come back to your window, and we're going to graph, and I'll tell you what that is. It's a fraction, so put in a fraction template, and it's 5 plus 3x divided by 20 plus 4x. And that also seems to match pretty well. Okay. Find the limit of each, or find the limit of the first one, and I think, let's see, this should be -infinity for both of those. Now we're going to stop right here because I do want to get your quizzes back to you. So we'll pick this one back up.